Numbers that we can count on our fingers are natural numbers like 1, 2, 3, 4 and so on. When we add 0 to the numbers which we can count naturally from 1, 2, 3, when we add a 0, it becomes a whole number. So this will be from 0 to forward. We can see on number line that there are numbers on the negative side also. So -1, -2, -3, -4 and so on, more towards minus side. So if we include all these numbers with the negative sign 0 and then the natural numbers 1, 2, 3, 4, they together make the integers. Now including all these numbers 1 or 2 or 3 can also be written as 3 upon 1. Similarly, a -4 or any negative integer can also be written as -4 upon 1. Basically what I am trying to say is that they can be written in terms of fractions. So any number that can be written in terms of fractions, that is p upon q, where q is not equal to 0. This is a given for defining any fraction. You cannot have 0 in the denominator. So any number which can be written in the form of fractions will can be plotted on the number line. So half will be somewhere around here, 1.5 will be somewhere around here, and so on and so forth. So numbers that cannot be written in the form of a fraction, that is p upon q, q is by default, it cannot be 0. So any number which cannot be written in the terms of fractions is irrational number. Examples of irrational number are prime numbers with under root or product of prime numbers inside under root, like 15. 15 is basically under root 3 into 5. And any number which is not terminating, which does not end, which is not terminating and not repeating. So any of this, we cannot find any pattern which is repeating again and again. So this is like an example of irrational number. Pi is a very classic example of irrational number. Similarly, there is E, which is also an example of irrational number. We'll see later on what is the meaning of non-terminating and non-repeating and how we are going to classify this in decimal expansion. So both these numbers together, the rational number and the irrational number together make the real numbers, and all real numbers can be plotted on number line. When we do decimal expansion of any number, either it will be terminating or non-terminating. Terminating example is, if we divide 3 by 8, then we'll put a decimal point, we carry a 0 here because we have added a decimal point. 8 times 3, 24, we get 6. We have a decimal, so we can add a 0. So 8 times 7, we have 56, we get a 4, 0 again, 8 times 5, we have 40. So this thing entirely goes in. The decimal expansion of 3 upon 8 is 0.375, and that's all. Here it ends. In case of a non-terminating, let me give you an example of 1 upon 3. So if I divide 1 by 3, then I add a decimal point, I put a 0 in front of 1, it goes 3 times. So 3, 3, 3, 9, again 1, 0, again 3, 3, 9, again 1 remainder, we add a 0 because we have a decimal place. So again 3, and this goes on forever. So this is not terminating. This is an example of non-terminating. In non-terminating also there is example of recurring and non-recurring. So recurring 1 by 3 is an example of recurring where 0.3 is recurring and number which recurs we put a bar on that top of that number. The example of non-recurring non-terminating number is under root of a prime, say under root prime 3. So if I'll expand it, it will go on like 1.73205 and so on. The numbers, the digits will not repeat and it will not terminate also. So I have made a basic classification how to identify and remember this. So all those decimal expansion of numbers, if we get any example in examination, we'll see later on how the questions are to be solved. So if a decimal expansion is terminating, then it is rational number. If it is non-terminating, then we have to check whether there is recurring or there is any part which is repeating. If yes, then it is a rational number. If no, then it is non-terminating and non-recurring and hence it will be irrational number. Rational numbers can be written in this form, that is in the form of fraction, whereas irrational numbers we cannot write it in the terms of fraction form. Examples of it is pi, e, and you can see 0.1201200012. So I mean there is no pattern which is repeating again and again, and neither it is ending, it is going on and on. So it is an example of irrational number. These numbers pi, e, and this 0.1201 and so on cannot be written in the form of a fraction. So these are irrational numbers. And rational numbers, on the other hand, these can be written in the form of fraction. The condition of fraction is that q cannot be equal to 0. So rational numbers can be written in the form of a fraction p by q. And here, how to identify by seeing the decimal only whether it is like terminating or it is non-terminating and recurring. So if it is terminating, it will end, right? So 0.25, 0.375, these are not repeating, they are terminating, they are ending there. We are not putting ... like here in this case. And if it is non-terminating and recurring, then it is like in case of 1 by 3, it is 0.333 and so on. It is never ending. So this one example, another example is like 1 by 7 or any number where the denominator does not have 2 or 5 or has 2 and 5 but another prime number in the denominator. So here I have summarized that if in the denominator, if in the q, if only 2 and 5 are there, then it is going to terminate. And if there is any other prime number like 7, 3, 13, any other prime number in the denominator, even if it is along with 2 and 5, then also it is going to be non-terminating and recurring. Let us go through the examples. Determine whether numbers are rational or irrational. So this is a decimal expansion. It is terminating. It is a rational number. This is a fraction. Since it is already a fraction, we can say it is a rational number. Let us write decimal expansion of it. So that will be 6 upon 15. We can reduce it to 3 2 times, 3 5 times. So this is 2 upon 5. And if we calculate it, it is going to come 0.4. So it is terminating. 17 upon 8. Let us solve through the example which I have told you, that if in the denominator only 2 and 5 are there, we can say it is a rational number. So 17 this is a rational number because it is written in terms of fractions, so we are saying it is a rational number. Also, how to know whether it is terminating, non-terminating, recurring, non-recurring? So it is 17 upon a can be written as 17 upon 2q. So here in the denominator 2 is there. So if in the denominator 2 or 5 are there, we can say it is a terminating decimal expansion. So next is 77 upon 210. It is written in fractional form, so it is rational. But let us see whether the decimal expansion is terminating or non-terminating, recurring or non-recurring. So if we reduce it, then it is 11 upon 30, which can be written as 11 upon 3 into 2 into 5. So in this case, in the denominator 2 is there, 5 is there, but 3 is also there. And 3, if it is there, then according to this, we can say that it is going to be non-terminating and recurring. So it is non-terminating plus recurring because 3 is there apart from 2 and 5 being there. Similarly, here in this case, 1 to 9 is not divisible by 5, 7 or 2. But 7 is already there in the denominator. So we can say that it is again non-terminating plus a recurring decimal expansion. And of course, because it is written in the fraction form, we can say it is a rational number. Pi is an example of irrational numbers. Over here I have given values till like here only, but it can go on and it is never ending. It has no end at all. Similarly for E epsilon, so here again I am giving you the value and it's going up till like 3527, but it goes even beyond. It is never ending. It has no end. It will keep on going on and on after the decimal place. This example is classic in the NCERT, so it is 0.120, 0.120, but there is another 0. Then 120, then there are 2 zeros. So, I mean, we cannot find any one particular expression which is repeating again and again. So, and it is never ending. So, it is a decimal expansion which is non-terminating and non-recurring is irrational number. These two are also examples of irrational numbers. Then 43.123456789, is this rational or irrational? It is a decimal expansion and it is terminating. So it is a rational number. Here in this case, it is a decimal expansion plus it is non-terminating plus, is it repeating? There is a bar over here, right? So it is recurring. So non-terminating, but it is recurring. So it is a rational number.